So welcome again. We want now in this last part of our first lecture on neural networks, we want to see a few examples just to have some fun looking at something. You should generally aim to try things out in this class because AI is such a tangible thing. There are computer programs, and you all have computers. In some sense, you have your mobile phone. Most of these examples run in a web browser on the internet, so you can just click on them from wherever you are. Some are videos that you can watch on the internet. And there's really no reason not to try them out, because you will understand much better how things work, and you will have a much better grasp of how this whole thing operates if you try out a few things, right? And since they're free and they're there, it's a pity not to do it. So here are some interesting things you can try out. First, here is a neural network that recognizes color contrast. Click on this link. And let us go there for a moment. Here we are. This is the neural network that recognizes color contrast from the previous link. Now, what does this do? The point is that you train this network to recognize, to remember what for you is a pleasant color contrast that you can read easily. You see here you have two examples, the left and the right. Both times the word "this one" is printed on top of a background, one time in black, one time in white, and the background is the same blue, so that the left on this image, the left version, has less contrast because the blue is pretty dark. The right one has a better, stronger contrast because the blue is still pretty dark, but now the text is in white. So here you would click on the right one to tell the network that you prefer the right one. In this way you train it. After you've trained it for a while, you can stop training and you can ask the network to perform itself and to choose the right color contrast for you for a particular background. So let's try this. I will now click on the right, this one. Now here we have again to think which one we want to say is easier to read. For me, I would probably say the left one. Here clearly the left one. Here perhaps the right one. Here very clearly it is the right one. The left one is almost unreadable. Here it is probably the left one. Here it is the right one. Here it is the right one. Here it is the left one. Here it is the right one. Okay, so this should be enough. I can now say train the neural network. And now I get the predictions of the neural network on the left side of the network I trained. This is why it says your network. And on the right side, I get the prediction of a formula that is used to calculate color contrast. And you can look up the formula if you are interested how this exactly works, but this is a standard formula used for this purpose. And so now I can compare the two, and I can see whether my prediction is according to the formula or not. So in this case, we decided the same thing. In this case, the formula says I should have used the black color, while I preferred the white one, and I still think that my choice is better than the formula. But this might also have to do with how my screen is calibrated. If you have a different colors on your screen, brighter or darker, then it might turn out differently, right? Obviously, if your screen is relatively dark, then you will see the left one better. If your screen is brighter, you will see the right one better. Here again we agree. Here we agree. Here we agree. Here we agree. Here we agree. So we managed pretty well to agree with the formula. Now, here's the difference. This is strange. The left one really is not good to read, so perhaps we did not train it optimally. Now you can try this also. You can try, how do you try to prove that this actually is doing anything? I mean, you could question, did I even train anything? He might just be giving me what the formula says with a few random, changes. So in order to see if this works, a trick is to try to train it to do something crazy, do the opposite of what it is supposed to be doing. So now let's train it to recognize the worst color contrast. So in this case, the right one, here the left one. So then we know if the training is successful, we should always get some totally unreadable text. And I'm doing this now. I'm always clicking left now. This is probably here the most unreadable. This is here. This is on the left side again. This is on the left side clearly. This is on the left side. This is on the left side. This is on the left side. Okay, so perhaps this is enough. We have trained our network sufficiently. And now we can say train the network. And now you see my network actually, as expected, gives me a terrible result on the left, right? And it completely disagrees with the formula almost every time. So this shows that really this network was trained according to my preferences, and it gives me a bad result, except when, it happens that the activation of the neurons is such that accidentally I get a good result, right? I didn't train every single color, so sometimes it might happen that my network predicts wrongly, as measured against what I wanted to achieve, wrongly, and actually produces a readable contrast, like here, for example. Okay, so that's one thing. What you should also see here is that I can look at the code. And if I look at the code, go down here, you will see my neural network is trained, and here is how it has been trained, right? So this is cool because you can actually see the weights. And these are the synaptic weights that are used in order to produce that result. And there are neurons for red, green, and blue, RGB, and here are all the weights. This is interesting, not because you could perhaps try to read the weights, but because the opposite is true. You cannot read them. And this is what makes it interesting. It shows you that synaptic weights are impossible to interpret for a human being. You cannot read this and say what this network is doing. A network that has, you can make a network that has been trained to show maximum contrast, then train a network to show minimum contrast, and then look at the weights. And you will probably not be able to see why. You will be unable to say what happens here and why this network, whether this is now maximizing or minimizing contrast. If you look only at the weights, you will not be able to say, right? So again, this emphasizes what we already said, that it is impossible from looking at the weights to have an idea of what your network is actually doing, what it has learned to do. In this case, whether it maximizes or minimizes contrast is impossible to say from looking at the layers, right? Here the code for the formula. Here you can see the formula. This is the formula that is used for the color. So you multiply red, green, and blue with some values and then divide by 100. And then in a binary way, if the result is greater than 128, then you print black as you print white. Okay, so this is one example of training a neural network that you can actually train with a few clicks, because normally training of neural networks takes a long time because you have multiple neurons, you have hundreds of neurons. They all need to train in this backpropagation style, and it will take longer than you want normally to wait in front of your computer. So this is a nice example because you need so few neurons that you can actually train it in a few dozen steps just by clicking the right thing. A very nice page about deep learning and particularly reinforcement learning is this one, which I give you the address of, wait, sorry, this is the wrong presentation. We have multiple topics here. So this here is the right one. This is the address of what we are seeing now. And you can enter this address yourself. It will bring you to this page. You can also just search for this word conf.net.js. This is a library that you can use if you program yourself in JavaScript. You can use it to create programs that use a deep neural network. And you have examples, very classic examples here of neural networks with digit recognition. And the nice thing is here you have the digits and the predictions, and you can see now every 1,000 cycles or something it prints out what the current state of the learning is of the network. So this here is currently identified as a 7. This is 4, right? So you see the green ones, the first prediction is green, so it's correct in most cases. This here is wrong. This is recognized as an 8. This is recognized as an 8. So some are still wrong, but as the network learns, you will see that it gets better and better. And you can see the different layers of the network here. So each box is one layer, the white box and the pink box and the purple box and the other blue box here and so on. Each is one layer, and you can see how the activated neurons are. This is what the activations are, the neurons that fire at this point, that get an input signal and that fire. And obviously the input layer just gives you the activation of the input, but then here you already see that the neurons, the more you get, the deeper you get into the layers, the more the neurons try to, or the visualization diverges from what is there, because you see how the neurons interpret what is coming in. And here you see the results if you go down a little, and then you can see which are easier to train for, which examples, and which are harder, which are more confusing. And then here you have a diagram of the loss of the error function. So you see how the error gets less and how the accuracy increases, right, of this network. Okay, you can do other things here, recognizing let's go down a little. Here you see what it actually does. Example predictions. It recognizes the content of images. You can see down here. But if you make it a little bigger, you will see why this is pretty bad in its performance, because the pictures, in order to let this run in the browser so quickly, the pictures have to have very few pixels, right? So these pictures are very rough. I don't know what it is, 20 by 20 or something, 30 by 30. They're very, what does it say? Somewhere upstairs it will say if you go up. And you see that even for a human, it's relatively hard to recognize in all cases what these are supposed to be, right? What the images are supposed to show. So for example, here, now look at the first line. I have this, which now is highlighted, truck, horse, or frog. I wouldn't be able to say what this thing is. For me, it looks like a gorilla or something standing there. So it's really hard sometimes. And so you cannot blame the neural network for being unable to identify what these things are. In some cases, in some other cases, it's more clear, right? Okay, so you should try these things out. And here you have the code. This is so beautiful because here you get all the code and you can see exactly how it is built. And you can see how, again, it converges and how accurate it is and how many examples it has processed and so on, right? All these things you can see up here. Let's go out. The last thing I want to show you, which is really cool, is this here. This is the example about reinforcement learning. And here you have a little game area in which are good and bad food sources. These are the red and green bits, and the green ones are poisonous and the red ones are good. And you have this little creature there that runs around at the bottom of the screen now, and this creature runs around more or less randomly and tries to eat the good ones and avoid the bad ones. It should avoid the green ones and it should eat only the red ones. And this creature is not trained in the beginning. It runs around randomly, and its movement is controlled by a set of neurons that react to the inputs, and the inputs are what you see. These lines that extend from this creature are the sensors, where the sensors are looking. So whatever is a line here is what is covered by a line is what the creature sees. And you can see the creature cannot see in the distance. It can see only to some limited distance, but it can see and it can distinguish green and red. But in the beginning it doesn't know which are poisonous and which are not. So what happens is that now every time it eats, remember this is reinforcement learning, every time your creature eats a red one, it gets a positive reinforcement signal. It gets told, this is good. And every time it eats a green one, it gets a negative reinforcement signal. And its goal is to maximize the positive reinforcement and minimize the negative reinforcement. This is what it's supposed to be doing. And so now every time it gets a reinforcement signal, positive or negative, this will affect the weight in its neural network. Every time it gets a positive signal, it knows that the weights are good. It's doing something right. Every time it gets a negative signal, it knows that whatever it has done previously was bad. And then it has to try to adapt, to change its weights in order to perform better. And now this takes a long time to train. Up here it says 10 minutes, but this is probably on a machine that is much better than mine. So if you wait here, it will take quite a lot of time to train. And if you come back, perhaps after half a day or a day, then you will see that it is trained optimally. And then you will see a big difference in the behavior of this creature. Right now you can cheat a little because you can say load network. So this then will load a network that is fully trained. And if I press this button, it's immediately loaded. Here it is. And you see how differently the creature now behaves. Now it doesn't run around randomly. It has learned that it has better chances of catching something if it goes in a direction for a time without always changing. And it has also learned to eat the red ones and to avoid the green ones. Right? Clearly now, although the place is full of green ones, it avoids them because they are poisonous. And instead, it keeps going around until it finds a red one, and then it eats it, which doesn't always work. You saw just now it missed a red one, and now it accidentally ate a green one. So it does not always work, but most of the time it manages to do the right thing. Exactly. And so this has been learned with reinforcement learning. So every time it does something good, it gets reinforced positively. Every time it does something bad, it gets reinforced negatively. And from this, the neural network tries to adapt its weights in order to maximize the reward. And you can see here some explanation how it works. The explanation is not very detailed, so you need a little background, but you can find explanations on the internet that explain this kind of thing perhaps a little better. And anyway, what you need for this class you already know. And here you have the full code of this. Please go also try to read the code. It's not difficult, it's very well commented, and try to make a sense of it, at least a little, to have some idea of what is happening here. You should the goal is not to become a programmer. The goal is to be able to see this and not to say this is magic. You should be able to look at this and say, okay, this is a piece of software engineering, and in principle I understand what this is doing, and in principle I understand how this works. I might not be able to follow the JavaScript code because I'm not a programmer, but I can understand what the principle behind this is, and how, if I knew how to program in a particular programming language, how I would go about implementing it, because I can understand the principles. Or I can tell somebody who can program how to program this. If he does not know about AI, I can explain the AI part to him, and he will be able to program this with my explanation. Okay, so this is the goal you should always have. It's not necessary to know how to do these things, but they shouldn't be a mystery. They shouldn't be magic. There should be something that where you can understand the engineering this is based upon. Okay. Yeah, so let's go back. This was, I think, the last page here. There is some more, which is again my book, which I try to sell to everybody who will listen. So this is my book that you can buy if you like. But otherwise, we are finished here. And next time we will still talk more about neural networks. We will see more examples. We will see also how they go wrong. But for the moment, that's it. Okay, so enjoy playing with these examples and see you next time.